Okay, welcome guys. Let's take a look at a graphical result here. So imagine we have the limit as x goes to 0 of sine of 2x divided by x. So as the title states, we're going to explore this graphically, so it's for a visual thinker. So if you graph this function at first, let's take a look. You're going to have sine of 2x over x. So look at the little box here, pause the video, just look at it. And when you do that, you need to zoom in. Now, where do you zoom in? Well, notice that here it says the limit is as x is going to 0. So that's telling us when we zoom in, we should zoom in around this location right here to look at the shape of the graph. So that's what the graph looks like. Algebraically speaking, we may not be able to find the limit, but visually speaking, we can tell that it's 2. Right here, where I'm pointing, that's 2. So we're going now to use the graph as a guide for helping us to understand how to transform this limit the right way so we can find it using the following more fundamental limit. The one you should have learned in class already is the following. The limit as x goes to 0 of something like, say, sine of some expression, and then here is divided on the bottom by the same expression. So this is one that you should have learned in class, where the expression here is the same as the expression here. What does that mean? So for example, it could look like 2x over 2x. This limit is equal to 1 right here. Or the limit as x goes to 0 of sine of 4x divided by 4x. That's equal to 1 also. So this is something you should have learned in class, but in case you didn't, let me show you what this is telling us, okay? So let me move this down a little bit. Let me make another graph. Look at these limits when I graph them. Sine of 2x divided by 2x on the bottom. So when you do that, again, you got to zoom into the right location so you can see what the graph is telling us. So you see, this is sine of 2x over 2x. You see this value is 1. To the other one, sine of 4x divided by 4x. That value is also 1 in the limit here. I mean, we're talking about the origin here, correct? Here. See that? It's 1 for both of them. The other parts are different in shape. Okay. You see they look match here. They're both 1. Now, so this applies when, look very carefully, when this number here is the same as this number here, when the 2 is the same as the 2 here. So in general, what you have as a rule is you have the limit as x goes to 0 of something like sine of some function in here, some function, divided by the same function on the bottom. Right? So like above, in one of the examples, we had this, f of x, and one of them was equal to 2x. And the other one, let's say f of x is equal to 4x, and so on and so on. These pieces have to match. They have to look identical to the eye. So then you can say the limit as x goes to 0 of this sine of f of x here, divided by f of x, then it's equal to 1. Right? So if you have to pause the video, we're doing a graphical exploration and really try to connect the graph on the right to what these are telling us. And then look very carefully at these expressions here, and then specifically, right? This and this match. This and this match. So the value of the limit is 1, and the value of the limit is 1 in both cases. Okay, so with that understanding in place, now we're going to do the following limit. The limit as x goes to 0 of sine of 2x over x. So this is different because here, x on bottom is not 2x on top. Stop for 1 second, look at this carefully. These are not the same things anymore. Okay, so you cannot just say that this is equal to 1. So not equal to 1 for sure. Okay, so we are going to do a graph because we're doing a graphical exploration. So the graph will look like this. We're going to do sine of 2x divided by x here on the bottom. And look at the way this looks here, okay? It looks similar to the other ones, yet it's a little bit different. What's different is, as you can see, right here where I'm pointing, there's a value of 2 for the y-coordinate. So as x approaches from the right or from the left, the y-coordinate slides up from below towards positive 2. So what does all of that mean if we were to represent it in pictures? When I come from this direction, the y-coordinate, the points on the graph move this way, which means the y-coordinate comes up from below towards 2. If x approaches from this direction, again, the points on the graph move this way. That means the y-coordinate again comes up from below towards 2. The value of the limit is 2, in other words. Okay, so what we want to do is be able to do this algebraically. So now here we have the following. This is 4 and this is 4, this is 2 and this is 2. And we know these limits are equal to 1 each. So what we're going to do is we will do the following. Whatever transformation we perform, we have the following then. The limit as x goes to 0 of sine of 2x over 2, or x rather. There's a 2 that's missing here on the bottom. Here, there's a 2 that's missing. Can I just put a 2 on the bottom by itself? No, I can't. Why not? Take a look at this graph. Right? Imagine you just do sine of 2x over x. This is the let me put that division bar. This is x, but then you just randomly here put a 2 by itself. You're just putting a 2 on the bottom. Okay? It's no longer the same thing. Look at the graphs. They do not match anymore. Right? So we cannot just take random steps in math. What's the only step that's really allowed? Here's the key. We can multiply by 1. How many forms of the number 1 exist? Infinitely many. But that's really what you can do. You can multiply by 1. Right, look, again, the green graph here does not match the black graph. That means you cannot just randomly put a 2 on the bottom without making a proper and full adjustment. So this is how to do it. You're going to do limit as x goes to 0, and you're going to put a 2 on top times sine of 2x, and then the bottom you're going to have 2x, like that. So there's a 2 here, and there's a 2 here. Why is this different? Take a look, graph it here, the red graph. 2 sine of 2x divided by 2x. You see how now the red curve and the black curve, you can't even tell them apart. They overlap. So it's telling us something really important, which is the following. Give me a second here. I get this little thing floating around. Let me move it aside. It's telling us that what? That this thing here and this thing here are identical. These are the identical ones. You can tell because the black and red graphs I've made here overlap perfectly. Why do we want this one here? Why is this better? It's better because then, by the laws of limits, this too, right there, that I've highlighted, can be factored out. You can put 2, limit as x goes to 0 of sine of 2x over 2x. But this red part, the limit is known to be 1 from above, I showed you. So you're going to have 2 times 1, which is 2. And this is how you can think about motivating these steps using graphs, and not just... So if you like this kind of stuff, these kinds of graphical explorations, please be sure to subscribe and like, and thank you so much for watching. I'll see you in another video.